ZenML recently released integration into Seldon. There's this really nice diagram. I'll zoom in a bit on this so you can see it, right? Oh, maybe not that much. But the idea behind it is you'd use ZenML. Typically, lots of people are using it right now to kind of automate training, evaluation, all of that kind of stuff. So it might be like, importer steps and then regularizers and different training parameters and so on, and then evaluation. But now ZenML have built deployment, like a deployment, I don't know what the right term is for it, but it's basically like a deployer concept. And what that does is allows you to define an endpoint that your model will then get sent to after it's been trained. So again, you'll see more of this in the example. Will probably make a lot more sense, but this nice little graphic kind of shows you, you might pull data in from a feature store, train it, evaluate it, deploy it to Seldon, and then in this case, run it on top of Kubernetes. Cool. So I think the easiest way to show you this is just to show you some code. So what do I call it in here? Cool. Hopefully you can see this. I'll make it a little bit bigger because I know when screen sharing it's not always the best. So if you're totally new to ZenML, the way it does it is with these really clever little decorators for your Python function. So the two things you will probably need to know about most are the concept of a step, and that's essentially like any kind of step within a pipeline. It is kind of what it says on the tin, but it could be, in this case, we've got an importer step, which is going to take, import the data, split it into test sets and training sets. The second step we have here is a trainer. So that's going to go away and train. In this case, it's going to train a very simple scikit-learn model. And then another step might be an evaluator. So once I've trained a model, can I evaluate it against some sort of test set or cross-validation set and see how it's performing? So those are steps, right? It's kind of like individual tasks that you might do as a data scientist or machine learning engineer. And then the way you bundle these together is in something called a pipeline. So again, I define this with this pipeline decorator. And then I simply list my steps in there. So I've got an importer, trainer, evaluator, and then tie them together in terms of the variables that I might pass through. So in this case, I'm gathering my training and test sets, and then I'm going to run, find my model as being the output of my training step, and then I'm going to run the evaluator on the model, including the test set that I had for my importer. And then I simply define that, and I can just do pipeline.run. And so let's actually show you this happening. So let's come over here. Oh, you've got a full screen. Interesting. All right, let me send this down here. Again, I'll make this a bit bigger. Okay, so I can just do Python run.py. And ZenML will now run that pipeline for me. So what you can see is it says using stack default. We'll talk about stacks in a minute. But then it's running my importer step. It's timing it. It's running the trainer, timing that, doing the evaluator, and putting out the output of that. Which, if you noticed in the code down here, my evaluator prints the accuracy for my model. Cool. So that's a very simple pipeline within ZenML. And the idea behind this is these are like super reproducible. And just by adding those Python decorators, it adds tons of cool functionality to it. So all of the inputs and outputs of each of those steps automatically logged, tracked. So if I go in and let me just change something in here. So you'll notice I disabled the cache on my pipeline. If I run it just by default and run the same thing again, this should run much quicker, right? And you'll notice what it's saying here is using cached version of the importer. So like it's going to say, oh, you don't need to import that data again. You've already done it before. It's automatically caching the steps within my pipeline that I need. Fine. So there's a kind of very quick rundown of what ZenML is. So how does that work with Seldon? So we have this example here, and again, kindly built by the guys at ZenML. So give them a big shout out for this. Really awesome that they build these examples for pretty much every integration that they work with. And what we're going to do is we're going to run through the fashion MNIST data set, which is just a bunch of images of clothes. If you're not familiar with it, it's very much like MNIST, right? It's a very simple classification problem. And then we're going to train models either using TensorFlow or scikit-learn. And then we're going to, at the end of that pipeline, it's actually going to add a deployment step, which is going to automatically deploy the model straight to Seldon Core running on a Kubernetes service. So I guess this is where I might need to explain a few more things. So we talked about steps and pipelines. Oh, what is that? Things in the way. But then there's also this concept of a stack. So if you look in the middle here, this is the pipeline, right? And I appreciate this diagram looks a bit confusing when you first see it. If you look straight down the middle, you've got kind of source data, split, pre-process, training, deployment. Right, that's pretty simple. That's our simple pipeline that we're going to run. But if you look over on the left-hand side, there's in this big box, right, which is, I don't know, probably zoom in a bit more. You can see on the left-hand side, everything in there is what's defined as a stack. And a stack is essentially your reproducible endpoints or like configuration of tools that you would use to run pipelines. And why I love ZenML is that they're totally agnostic of the tools that you use, right? So it doesn't matter whether you're using DVC for data versioning or Seldon for deployment or Feast as a feature store, right? It doesn't matter at all. And what ZenML does is it kind of decouples you from all of those and allows it to be totally reproducible regardless of where it deploys. And that's what's really cool. So the way you define that is in something called a stack. And I think I might be able to show this here actually. So let me just move to my other example. And then I can do, I think I can just do this, right? Again, I think Alex from ZenML is on here. So what have I done wrong there? ZenML stack list, maybe. Cool. Yeah. So what you can see here is that there's like this default stack, which is just runs everything locally. And ZenML will automatically track stuff, stick it in its own artifact store, have its own metadata store, and orchestrates things. But you can also define your own stack. So maybe it's like you have a local stack that you use for development, uses a bunch of dependencies on your own machine, and then you have a production stack that actually uses S3 for your artifact store, uses some sort of maybe ML flow for your metadata store, uses Kubeflow as the orchestrator, and then deploys it on top of Seldon on, in this case, like an EKS cluster or something like that. And you can chop and change all of the tools that you replace in the stack, and then deploying stuff or running the pipeline looks exactly the same. ZenML handles all the different integrations to those tools. So whether I run this, if I change my stack to local or default here and just run it, everything runs locally. And then I just do, ZenML stack set, in this case, I've now got another one with like local with AWS, right? Then it's now going to run, in this case, you can see the artifact store is now sitting on Amazon. So whenever a model is trained, it's actually going to get pushed to an S3 bucket. And then I also have a model deployer that I've configured in here. I call it Seldon EKS. Actually, in this example, I'm going to run it locally on a kind cluster. But you can see again how it doesn't really matter what the where the kube cluster is, where it runs. You just define the thing in a stack, and then the whole thing runs from there. You make this a tiny bit smaller because we need some stuff. Okay, where I got to. Any questions at this point? I realize there's a lot of information to take in. Cool. All right. Well, I'll continue to run through some of the stuff in this example. I had a bunch of notes to remember that I should go through, and then realize I don't have a second monitor here because I'm in a meeting room. So apologies if I have to tab back to here every now and then. Cool, so we talked about stacks. I've shown you the list of the stack. Oh, what I didn't show quickly was the integration is literally like as simple as this. So you go integration, install Seldon. And ZenML, in my case, it won't actually do anything, right? Because I've already got the dependencies in there. But that works for anything, right? If I wanted to do, integration, install ML flow, right? Then ZenML is going to install all the required dependencies, etc., and all of the relevant deployers and so on. Like if I want to deploy it locally on MLflow, or if I want to send my metadata to the MLflow metadata store, all of that kind of stuff. Cool. So the next thing I'm going to do is, in fact, let's run through the example quickly, because one of the really cool things that this Seldon Core integration does is it doesn't just kind of spit out a manifest and then run a kubectl apply, right? Which is kind of what I'd assume would be the easy way to integrate with Seldon. It actually automatically integrates with the rclone secrets. So if you haven't heard of rclone, that's the tool we use underneath to pull model artifacts from things like an S3 bucket or GCP or Azure storage or file store or whatever, right? It's a tool that supports like all the different clouds. And underneath, if any of you have used Seldon Core in any kind of like production setting, you'll have played with it already, because you have to define a secret in there that allows Seldon to go and connect to your object store. And so the cool thing with ZenML is that they handle secrets automatically within the stack. And then when you run a deployment, it creates that secret for you on your Kubernetes cluster, allows Seldon the access to it to be able to go and talk to your artifact store. So again, in my code here, right, where you see that my artifact store is now AWS because I'm using this stack, that secret has been configured automatically. Okay, any questions? Cool. Fine. So let's actually run some stuff then. So I'm going to do a kubectl get pods. This is in a what was the namespace called? ZenML workloads, I think. Okay, and we'll just watch that. Make it a bit bigger. So what I'm doing here is just watching the pods in that namespace on my kube cluster. The reason I want to keep an eye on this is because you guys will want to see the actual deployments as they get spun up. And then before we run anything in the Seldon example, let's jump into the code very quickly so you know what's actually going on. So there's this pipeline py file. And it's very much like the example I showed earlier. This is just slightly more sophisticated. But you'll see there are still these steps in here. In fact, this data importer looks very similar to the one you saw earlier. In this case, I have a normalizer. I then have a TensorFlow trainer. And again, one of the cool things you can do is add like configuration parameters in there that you can set at runtime. So if I want to rerun the whole pipeline, but I want to change like the learning rate or the number of epochs or whatever, I can do that without having to go in and alter the code. And ZenML will track it all. I've got an evaluator, and then in this case, I actually have a scikit-learn trainer and a scikit-learn evaluator as well. So maybe I want to swap in different types of framework and see what types of model are going to perform well on my data. And then I have this step deployment trigger, and then a prediction service loader. So what I'll show you, the important bit is this pipeline down at the bottom. So this example actually has two pipelines. The main one is this first one, so this continuous deployment pipeline. And you can see what happens is the data gets imported, then there's a normalizer, trainer, evaluator, deployment trigger, and then model deployment. The deployment trigger, right, in this example, is basically testing against the output of the evaluator and saying, if the accuracy of the model is above a certain threshold, we'll deploy it. But if not, don't bother. And that's really important because obviously in a reproducible pipeline, you don't want to just train every model and then deploy them all straight away. You maybe only want to deploy the one with the highest accuracy or ones above a certain threshold. And then finally, there's a second pipeline in here, and that one's defined to run inference. So this pipeline is just to show you how you can actually run dynamic inference against a live endpoint, which we will do in a minute. Okay, so if I jump back over here, I can just run this. So I can go Python, apply, deploy, and then I think I can set things like epochs equals 30. So let's see, I might have got this wrong. But what should happen is I will run through my pipeline and it should train a TensorFlow model with 13 epochs in here. Okay, which hopefully will be quick. I do have a GPU on here, so we won't be waiting too long. Okay, good. Feel free to ask questions over the next 7 epochs if you're fast.
How does the model get into blob storage? Does the Seldon deployer component have the credentials to put it there, and the model has the credentials to pull it from there, or how does that happen?
Aha. Okay, so that's actually what's just about to happen. So very good question. Is that when this model is trained, it will then get, so as I mentioned, ZenML keeps track of everything and stores all of the artifacts automatically for you. But because I've defined my artifact store for ZenML to be an S3 bucket, what's happening here, you see, in fact, there's a line here. ZenML is going to automatically write the output of my model, so my trained model file, to my S3 bucket. And then, so that's now in a remote S3 bucket. The way that Seldon then accesses that is it will get given this URI, like we're used to passing into Seldon is, here's my model URI. And the bit I was mentioning earlier is that I don't need to go in and configure Seldon to use the same secrets that I have done within ZenML, because ZenML automatically passes them to the Cube cluster for the deployment to use. So it's pretty neat on that front. Okay, cool. So what you see is my model's finished training. It got written to an S3 bucket. And then the deployment trigger, okay, passed because it was accurate enough, this 92% accuracy. And now it created a new Seldon deployment for me. And if I jump over to my tab over here, you can see that it's actually spun those pods up, and I now have a Seldon deployment running on my Kubernetes cluster. And that was all within this reproducible Python pipeline from ZenML, which is really cool. And then what I can do is, you see it's spat out the prediction URL. Again, another kind of neat feature that it does. Rather than you having to go and dig in and understand what the makeup of that URL is, it's all done automatically. But I can now run, let's run the prediction pipeline. And we'll actually run some live inference against that deployed model. Okay, cool. So what you'll see here is, again, it's using this dynamic data importer and what that does is it goes and grabs a bunch of test data for this fashion and this model. And then it's going to do some pre-processing, fire it at our model, and you can see that it spat out a bunch of predictions. So this batch request had, I don't know, whatever that is, 50 different test samples that we fed through. And if we wanted, we could go and compare these labels with the actual classes to check that it had made the predictions correctly. So that's pretty cool, right? And then I guess something I wanted to show was that ZenML, the reason you design these pipelines is because they're totally reproducible. So if I wanted to, I'm just going to go and get my, here we go, my command. So if I wanted to rerun this whole pipeline, but this time swap in a scikit-learn classifier instead, then I can do that, right? I can run, so in this case, I'm still running the same thing, the deployment pipeline, but maybe I'm setting the threshold a bit lower because I'm not sure how accurate this model will be. And then I'm running model flavor scikit-learn. And what that will do is that swaps out the TensorFlow trainer and the TensorFlow evaluator and swaps in the scikit-learn one instead. In fact, you can see it didn't even bother training the model because I ran this earlier. And so where's this training? Yeah, here. You see this highlighted section saying using cached version of scikit-learn training. So that typically would like take about 25 seconds. It didn't even need to do it this time because it said, you know, all your data is exactly the same. You're training with the same parameters. So I'm just going to use this cached model I have earlier. And then what's going to happen is it's going to run through it and it's going to replace my deployment with that because the accuracy sits above this threshold that I've defined. And we might see a change. We won't see a change over here yet. Cool. Any questions? Is this making sense? It's kind of hard when I can't see anyone other than myself and my screen. So you know, shout if I'm you know making no sense at all.
That makes sense. That makes sense.
Cool. So the final thing to show is some of the actual like ZenML integration. It has this like serve models thing. So I can do ZenML serve models list. So now I've got a model deployed out there. I've replaced it with my scikit-learn one, or you know, shown that I can rerun these pipelines with different parameters each time. But the integration also like will pull back the live status of my deployed models, which is really cool. So you know, you can see here my status is green. Here's the unique identifier for that deployment. The pipeline that was used to run it, because you might have lots of different pipelines. It kind of depends on the use cases and what type of models you're building. And then my model name itself. And even better, I can do a serve models describe. And then if I give it this ID, it'll actually give me like a ton of information on my Seldon deployment. You know, one of the things that we hear from people a lot is like, it's a bit of a pain to figure out what my prediction URL is. Well, ZenML's already like automatically built this URL for you because it knows where you've deployed it and how the route is built up. So you can pull that straight back with the ZenML CLI, which is really cool. And it's showing, you know, again, somebody asked a second ago, I think was it Fabio, about like, where's that model getting stored? So ZenML, when it finishes the training, is automatically pushing it to my S3 bucket, which is called ZenML Seldon. And then this was the output of that pipeline run. So my, you know, whatever that was, run number 196. And then this is the model URI that gets passed to the Seldon deployment when the actual manifest is created and then applied to Kubernetes. But the cool thing here is that I've kind of got all the traceability all the way back to show like, here's the pipeline run ID that was used to train that model that's now deployed on this endpoint over here. So like, if I needed to, I could trace it all the way back to the exact versioned data set that was used to train the model. So like a super powerful way of adding auditability to everything we do. And then finally, I could do you know, let's do ZenML serve models delete. So I can actually, you know, I can delete Seldon deployment straight within ZenML now too. And what will happen here is it will go and remove that deployment service, and we should see, if we jump over to look at our Kubernetes pods over here, yeah, it's now terminating those 3 pods that were running, you know, for 7.5 minutes or whatever it was. So you know, now we're down to 2, etc. Cool. So I've like whistled through all of this. I appreciate that it's tons to take in, but the cool thing is you guys can do it yourself. So this GitHub repo talks you through how to do this Seldon Core example. And in fact, another thing I love about ZenML is you can even pull examples like this. So you can do like example pull Seldon deployment or something like that. I can't remember the exact, this is probably wrong, but the exact terminology you'd use. Oh no, there we go, cool. And it will pull down these examples for you, and then you can go and like, you can go and run them locally. So you don't even have to go and clone the right pieces of GitHub. It's all handled within the CLI. So yeah, kind of cool things I've done. I guess if anyone has any questions, please fire away. I don't know if Alex is still on.